And my approach came from the user's point of view, because my field of research is the excess water inundation in Hungary especially. So let me please first say a few words about this phenomenon. I mentioned that this is a special hydrological feature on the Great Hungarian Plain, and it can cause a lot of damage in the agriculture and in the transportation and also in the private sphere. And because of this, it's very important the investigation of this phenomenon. But this is very difficult because it has several influencing factors, for example, soil, climate, relief conditions of the surface, the land cover, of course, and the anthropogenic factors also, cultivation, river regulation, works, irrigation, drainage, and last but not least, the hydrology of the area. My aim was to investigate as a little part of my field of research the groundwater level on a lowland sample area. My time series data came for the period between 19 and 89 and 2008. And because this database was very big and large, I tried to find a fast and almost automated processing to make the analysis. First, I would like to show to you where is the sample area in Hungary. So, in Hungary, this area is located on the Great Hungarian Plain as a part of the Great Cumania. Maybe you have heard about these places as called Puszta, the Hungarian Puszta. But this part is not really the Puszta. The Puszta is a little bit in the eastern part. So this area is covered by Pleistocene and Holocene deposits. That means clay, silt, and meadow clay. The landscape is very monotonous. Only scattered sand dunes and loops, meanders, and mounds break this monotonity. And of course, on this area, we had earlier studies about the groundwater level analysis, and until the 1950s, the groundwater level was determined between 6 and 10 meters. And then later, this tendency showed a little increasing. And we will see that this increasing continued in the last 20 years. And about the fluctuation, the long period fluctuation is very high, especially on the south part of the sample area. It is between 4 and 6 meters. And later, according to other researchers and studies, they could not analyze, explore that kind of fluctuation, only 35 and 60 centimeter fluctuation. Okay, and so this slide shows that how many groundwater level gauging wells I had on the sample area. In Hungary, the groundwater level observation started in the 1930s, and then later continuously they built this system to a nationwide network, and now we have more than 2,000 wells in the observation system. On my sample area, there were only 53 groundwater level gauging wells, and as you can see, the distribution is not so smooth, not so perfect, but from that we can see also the characteristic of this area. Okay, and what was the process of this analysis? So in Hungary, if you need a hydrological database, you have to ask for the regional directories of environment and water, and if you are lucky, you don't have to pay for them. Yes, I was lucky, so I was able to get the database free. And there is a little problem with this database because the format is not suitable for the different hydrological applications and tools. And we didn't want to dedicate a lot of time to convert this database, and because of this we have made a little application written in Java in the frame of a collaboration on my department, and this application made me available to convert the database to a suitable text format. And this text format I could import to the hydrological application. I have used the HydroDesktop and the Hydro groundwater tools as well. Yes, the HydroDesktop would be better because this is a free application. And for the Hydro groundwater tools, you have to buy the ArcGIS softwares, and we know that they are very expensive. And what could you make if you make the import? Of course, you can analyze the time series data. You can see on this slide a tube graph, and the first was made by the Hydro groundwater tools, and the above one was made by the HydroDesktop. And of course you can analyze the trends, and then you can analyze the annual average, and from this data you can make interpolated maps. I will show to you a few. And what I liked especially was that with the HydroDesktop I could illustrate, visualize the monthly average, and Hydro groundwater tools is not able to show this kind of graphs. And of course, from these parameters we can draw conclusions for the direction of the. And of course, we analyze the minimum and maximum values to check the fluctuation, the short period fluctuation and the long period fluctuation also. And now we see a few interpolated map about the groundwater level changing. This map I have made with the Hydro groundwater tools. With this kind of maps we can see in which time is the groundwater level very close to the surface, And for me this is very important, because if the groundwater is near to the surface, the water inundation can form more easier. And then from this kind of maps we can make to make easier the analyzing the map about the groundwater level flow direction. And on that kind of maps we can discover that convection spots where the groundwater level, the groundwater can appear on the surface, because of course damage in the agriculture and in the agricultural lands. And more result, only see what is the situation on this area during the analyzed period. Of course, we can explore the annual period of the groundwater level. The minimum values appear during the autumn and the early winter, as you can see on the figure. And in the case of the maximums, we can see little regularity, because from the eastern part to the western part, the maximum values appear more and more later, from the spring to the early summer. And yes. And if we go on to check the fluctuation on this area, we can see that these values are more higher than in the earlier studies, and on the map is very well visible that near to the rivers, the long-term fluctuation is not so high, because during the arid period they can refill from the rivers, so they have in connection with the rivers. And if we analyze the annual average of the groundwater level between the analyzed period, we can see from the trend lines that generally the groundwater levels increased in the last 20 years. And we can separate three periods with higher groundwater level. And of course, if we check the precipitation data of Hungary, they are in very significant connection, because the precipitation maximums were in the same period. Of course, after another period, for example, between 2001 and 2004, came a year with more precipitation, and that appeared in the groundwater level in the next year. Of course, this is very important for me, for my research topic. And finally, I've showed you a few pictures about this phenomenon on the Great Hungarian Plain. You can see this is abandoned loops with filled with water, and it can block the roads between the agricultural fields, and the water can stay on the surface during a month, and it is very big damage in the agriculture. And yes, my presentation was very fast, so Finally, I thank you for your attention.